Okay, hey everyone. So in this video, we're going to be looking at perfect competition again. And we're going to be looking at restaurants that make bubble tea. And there's going to be 30 of them that we call high cost. All right. And their supply can be represented by 2p. No, what about the low cost? There's going to be 20 of these. And we're going to represent their supply with 5p. Okay. First thing we want to do is we want to find the market supply curve. Right? So we want to find the equation that represents that. Market supply. And so when we're doing that, we're trying to find the market supply curve. We'll add up all the individual supply curves of these firms that are high cost and low cost. So there's going to be 30 high cost. And when you add those up, you need to multiply the 30 by 2p. What about the low cost? Well, we need to add those as well. There's 20 of those. And to get how much they'll produce based on the price, we need to multiply this 20 by 5p. Okay. Well, maybe I should have wrote that so you can see exactly what I'm doing here. Let me rewrite this. So what I'm doing first is taking this 30, multiplying it by these high cost firms. This will give us our total supply that comes from them. And then we want to get the total supply that comes from these low cost firms. So we'll take the 20, multiply it by quantity these low cost firms produced. And so this is going to be 30 times 2p plus 20 times 5p. And what is that going to give us? 30 times 2p is 60p plus 20 times 5p is 100p. All right. So our market supply can be represented by 160p. All right, so that's our first part. Now, what's our next part? Well, we want to find the equilibrium price and quantity. And so we'll need to get the market demand. I'll write that here in a second. Let me erase this first. Okay. So we want to find the equilibrium price and the equilibrium quantity in the market. But we need our demand curve. So we're going to say the demand curve is represented by 1200 minus 50p. Okay. And so to get the equilibrium price and quantity, we just set the market demand equal to the market supply. Market demand is 1200 minus 50p. This is going to be equal to the market supply, which we just determined was 160p. Okay. So now all we need to do is just add 50p to both sides. This will give us 1200 equals 210p. And then to get the price, we just take 1200 and divide it by 210. What will this give us? This will give us a price of $5.71. So this is the equilibrium price of these bubble teas. Okay. Now, you can plug this into either the market supply or market demand and get the equilibrium quantity. So let's use supply. All right, this will give us our equilibrium quantity. Since we're using our equilibrium price here. This is going to be 160 times the equilibrium price. So that's 160 times $5.71. And what will this give you? 914.28. Okay. So this is how many bubble teas will be produced a day. All right. Think of this in terms of each day being produced. So that's in the city of Cleveland, there's on average 914 bubble teas served every day. Okay. What will we do for the next part? All right, so if this is the price, we want to determine how many does each low-cost restaurant serve? And how much does each high-cost restaurant serve? So we'll find each for each of those next. This will be C. All right, we'll do the high cost first. Oh, sorry. That's P. There we go. So the high cost is just 2 times the price. So 2 times the price we just found, $5.71. Well, we don't need that dollar sign. And so what that'll give us is the average each day is 11.42. So some days 11, some 12. What about the low cost restaurants? Here that's represented by 5P. Okay. So we take 5 and multiply it by this price that we got, 571. And so we'll get 28.55. So on some days, these restaurants will serve 28, some 29, something like that. Okay. All right. Now for the next part. So we want to find the total industry surplus at the equilibrium price. All right. Let's erase this so I can have plenty of room here. These next 2 parts are kind of connected. All right. So here's the price, bubble T. Here's the quantity produced in the market. And our supply, if you look at the market supply, 160p. So if they're producing 0, then there's not going to be any produced here. So the price is 0, none are produced. But as this increases, it will increase as well. What about our market demand? Well, we want to find our choke point. In our market demand equation, there's 1200 minus 50p. We want this to be equal to 0, so 1200 equals 50p. And so when the price is 24, no one will be willing to buy bubble tea. All right. And as the price goes down, more people will buy bubble tea. All right. And what do we find for equilibriums here? Well, we said at 571, we'd have an equilibrium. And the quantity is going to be 914.28. All right, so we want to find producer and consumer surplus. So the consumer surplus is going to be here. These consumers here, like especially the start, they're willing to pay a good bit more for this bubble tea. They really like it. So, but they're only having to pay 571, so they're getting a surplus here. Now, what about the producer surplus? Well, all right, anything above the supply curve here, all right, it means it's profit for them. So it's more than it costs for them to run and produce it. So this is going to be represent their surplus here. So let's get this consumer surplus first. Remember, to get to what this triangle is, it's just 1/2, right, times the base times the height. And so what is that? The base is just 914.28. And what is the height? Well, the height is 24 minus 5.71. Okay. All right. So what will that give us? When we multiply that out, 1/2 times 914.28 times, it's like 1829. Multiply all that out, you'll get a surplus of $8,361. What about the producer surplus? Use your same formula, 1/2 times base. Base is the same, 914.28. What about the height? Well, the height goes from 0 to 5.71, so you know it's 571. And so what will this give you? This will give you, all right, producer surplus of $2,610.26. So it's not near as much. All right, but that's our producer and consumer surplus. Okay, and so the last part, what if the average total cost was at $6? So this is the average total cost for the firm's producing or is maximizing profits. All right. So will firms want to exit the market here or they want to enter it? So so will the price be below that if it's equilibrium here? Well, yeah, it's lower than the $6. So let's draw a diagram and show what's happening here. So we want to show firms leaving. You show them leaving, reducing supply until the price rises enough where it's going to be equal to the average total cost. That way that profits will be zero. All right. So here's the individual firm. Erase that. So here's the bubble tea restaurant. Yeah. Okay. And so we're going to say their marginal cost is right here. Right. And so when the price is $5.71, this is where they're going to produce that right here. Okay. And we're saying the average total cost the average total cost here is going to be $6. Right. Remember our price here, where firms are producing. Remember, firms in a perfect competition, they're going to produce. We take the prices given. That's our marginal revenue. They're going to produce into this marginal revenue is equal to marginal cost. Right. So they're going to produce right here. What's going on here? Well, remember the price is $5.71. Right. So that means, producing each bubble tea, it costs more than the actual revenue they're going to generate. And so because some of these firms are going to exit the market as a result of this. Right. And so how does that occur? Well, you'll just see this market supply shift backwards. Okay. So what's going on here? Firms are going to exit. This reduces supply. But as a result of this, price will rise. So firms will keep exiting until the price rises to $6. And then at that point, you have this intersection with marginal cost, right where the average total cost is at $6. And at that point, firms will be getting zero profit. Right. And so no firms will exit at this point because like the profits are zero, and that's where things are in equilibrium, where no firms either enter or exit. Yeah. Okay. And so then you have the price equals the marginal cost equals the average total cost. So no firms will leave at that point. Okay, I hope that was helpful.